Hello everybody, Paul Sheriff here with Pluralsight. This course is the basics of unit testing for C# developers. This module is why you need unit testing. The goals for this course are to explore the unit testing tools that are available in Visual Studio. We're going to build your first unit tests right from scratch. We're going to learn to use the various assert classes and create some data-driven tests. And we're going to automate some tests using a command line utility called vstest.console. For this course, I am assuming that you are a C# developer, that you are familiar with Visual Studio, and most importantly, you want to learn to build unit tests, hopefully to improve the quality of your code. Let's get started. Let's start out with a definition. What is unit testing? Unit testing is where you're going to write code to test other code. That means you're going to write methods to test methods that you write in your various classes. We want to make sure that we cover all the code in your method. What I mean by cover all the code is that you have to include all if, case, do, untils, whiles, fors. Every case that might do some code in your method needs to be covered by a test. The reason we do that is then we know that every single piece of our code has been hit and that we know that it has then been tested. What's nice about this is that we can then run these tests over and over again. This is really important for regression testing. What that means is that, hey, I went out and I made a change to the code. I want to be able to run my tests over and over again, regression testing over and over again, to make sure that I didn't break anything that used to previously work. And that's what unit testing is. So, how am I going to illustrate this unit testing to you? Well, what we're going to do is we're going to do a file new project. We're going to create a class library. And in this class library, we're going to create a file process class. We're then going to create a unit test project, which is simply another project template that's available to you in Visual Studio. And then we're going to create several unit test classes over the course of this course to test out our file process class and illustrate some of the various assert classes that are available to you. We're going to build a series of unit tests step by step, and then we're going to run those tests and see them either succeed or fail. On the left-hand side here, you can see an example of the Test Explorer window that shows all of the past tests and maybe what tests have failed that you would then need to go back in and, of course, fix up. In this course, we're also going to take a look at some of the different assert classes. So we're going to look at assert, string assert, and collection assert. These are all different classes that we use to test various operations that might occur in our various methods. We're also going to learn to use code coverage tools. Now, this identifies those areas of code that you might have missed. Remember I said we need to cover all of the if statements and case statements. This is a utility that's built into the Enterprise Edition of Visual Studio, and it will tell you if you have missed any of the blocks of code in your method. We're also going to automate using vstest.console. This is simply a command line utility that you can run from a command file. This is very useful for doing builds and then running tests offline, like maybe at night if you have, a couple thousand tests that need to be run. This would be a good way to automate that process. Now that we know what we're going to do, why do we want to do this? Well, the reason why we test code is to ensure that that code works. Not only works the way you tested, but under varying circumstances with different inputs coming in. These are the things that you need to test to make sure that your code is going to work regardless of what your users are going to throw at you. We also test our code to improve the quality. What I find is that as you develop unit tests, it helps you focus a little bit more on the quality of the methods that you're writing. It helps you add additional error handling that you may not have thought of before. And really, for me, it helps break my code into smaller chunks. When you start having to write 10 tests for one method, you might start thinking, maybe I better break this up into maybe some smaller methods so that I can just test those methods then independently. So how do we test the code, right? We talked about the why. Well, one thing, we might have a QA department. And there's a lot of advantages to having a QA department at your particular shop. Sometimes different people will think of different things to test. They can test UI code easier, actually running a website and clicking on different buttons. Sometimes those are a little harder to automate. Also, it's less startup time. You can get the code written faster, so that means a little bit less cost maybe up front. But there's some disadvantages to having a QA department as well. Every time you have to do a regression test, it's more time intensive. If there's a lot of setup and teardown to do prior to running tests, again, somebody is sitting there manually doing that, that's also very time intensive and can be very frustrating for the testers and gets to be kind of boring for them as well. So a QA department is one way to go. And then, of course, there's what we're talking about here, which is automated testing. Now, there's some advantages to doing these unit tests and automating this. First thing, it's always repeatable. You can just run it. It's code that you run over and over again. You'll find if you take advantage of the tools in Visual Studio, you'll have better code coverage. Regression testing then becomes faster, and you can also automate the setup and the teardown. But there are disadvantages to the automated approach as well. That's more time up front. It takes you longer because you're having to write almost double the code now, because if you write a method, you now have to write the tests to test that method. That's more code. It's also only as good as the developer who develops the test. And it is also harder to test UI. There are some UI testing tools that are available out there. They don't always work 100%, and if you change something, you frequently have to go back and kind of fix them up. So which approach should you take? Well, I find a combination of both really works the best. Your QA folks should work with your developers to help them create the unit tests, help them with the setup and the teardown, and also help with the UI testing. So if you take kind of more holistic approach of having a QA guy working with the developer up front to actually develop the unit tests, again, two heads better than one, you might all think of different ways to do testing and different tests to automate. So the various testing tools that we're going to take a look at in this course is the unit test framework. This is a set of classes and tools that's available in most editions of Visual Studio. There's a code coverage tool that helps us determine if any methods have not been tested fully, or any code blocks, if statements, case statements, do loops, things like that. This is available only in the Enterprise Edition. Data-driven testing. This is where we read data from a table to actually guide testing. We'll take a look at this. And the command line utility, vstest.console, that helps us automate the running of unit testing, maybe scheduling it with the task scheduler. And it also helps us log results, so we come back in the next morning and we can take a look at what happened. In this module, well, we kind of learned that testing can be a little bit difficult. Unit testing does help with the code quality. Use a combination of a QA department and unit testing techniques, and we have great tools available in Visual Studio, which will be the focus of the rest of this course. Now, coming up in the next module, we're going to build our class library, we're going to add some unit tests, and learn how to handle exceptions.